Okay, so here's part 2 of proving triangles congruent. In this video, we will be doing at least two, maybe 3 proofs, depending on how much time. So each time, pause the video, write the proof down, and then start the video as I explain the proof to you. Okay, so here is the proof that we want to complete. We are given that segment AB is congruent to segment PB. We are given that segment MB is perpendicular to segment AP, right? That means perpendicular. And we got to prove that triangle MBA is congruent to triangle MBP. Okay? So, of course, the first thing we do is we write the given. That's the first step, the given. Right? Segment AB is congruent to segment PB. And segment MB is perpendicular to segment AP. And this is, of course, given to us. And if we go on our picture, let's mark that AB is congruent to PB and MB is perpendicular to AP. So we'll mark that. Now, look at what we're given. We're given one pair of congruent sides. Let's go ahead and put an S right here. There's one of our parts that we need. We need 3 parts, remember? Okay? So you almost, if you want to, you could put SSS, SAS, ASA, AAS. Okay, all of them involve at least one side, so all of them are still up for grabs. But maybe we can eliminate one of these ways as we go through. Okay, all right. Statement number 2. Well, if, let's look at this, okay? So for statement number 2, let's look at this guy right here. If they're perpendicular, then by definition they meet at right angles. We know a couple right angles here. Angle, now from the left side, angle MBA, that's going to be a right angle. And the same thing with the other side, angle MBP. So angle MBA is a right angle, and MBP is a right angle. This is by the definition of perpendicular lines. If 2 lines are perpendicular, then they form right angles. Then they intersect to form right angles. So what does that mean? What does this information mean down here? The fact that they're both right angles. Well, we have this thing called the right angle theorem. Very rarely used, I understand, but it might come into play here. The right angle theorem says it says all right angles are congruent. Angle MBA and angle MBP are right angles. They're congruent. They're congruent. Oh, you don't need to mark that. You know right angles are congruent. They're congruent by the right angle theorem. Look at what we have. We have one pair of congruent angles. Put an A there. Circle it. SA. So if you look at our possible choices, cross out SSS. We're not going to use it. We can't. SSS only involves the 3 sides. We're going to be talking about at least one angle. So now the question is, where does the other piece come from? And is it an angle or is it a side length? Well, it comes from the picture. Comes from the picture. Look at your 2 triangles. Make a note. The triangles touch, right? They touch right there. Side MB. This side is shared between both triangles, so it is congruent to itself. It is congruent to itself. Since the triangles touch, this side is congruent to itself. And that's the third side we need from each triangle. We say that side MB is congruent to side MB. It's congruent to itself. It's used twice. If we remember from chapter 2, where you have one thing congruent to itself, it's like looking in a mirror. It's the reflexive property. This is going to be a big property, I'll put a star, used a lot, especially when the 2 triangles touch. And this is our third piece. It's a side. So We cross off the two angles 1. We cross off the two angles 1. Here it is. Here's how they are congruent. And we're done. We have the side angle side congruence to show that triangle MBA is congruent to triangle MBP by side angle side. And there's the proof. There's the proof. Hopefully that didn't go so bad. Stay tuned for number 2 on the same video, of course. Okay, so here's our next proof. In this proof, we are given that segment WZ bisects angle XZY. Angle X is congruent to angle Y, and we have to prove that the two triangles are congruent, the top one and the bottom one. So, of course, our first statement is always the given. WZ, segment WZ bisects, that word bisects, we got to remember. Angle XZY. And angle X is congruent to angle Y. And this is all given to us. So we need to do some markings. Well, I don't know what bisects means right now, so let's hold off. But I know that angle X is congruent to angle Y, and there's one pair of angles. So in my list, side, 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 angle, side, angle, side, angle, 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 side, I have one pair of angles. So throw side, side, side. Not going to use it. Okay. But what does this word bisects mean? What does it mean if WZ bisects angle XZY? If WZ bisects XZY, well, we have to remember that word bisects means two congruent parts. It splits the angle into two congruent parts, which means that the angles here and here will be congruent. Now, we haven't said that yet. We need to say that in the next step. That is exactly what we're going to say in the next step. Right here. Okay? So, since segment WZ bisects angle XZY, we can say that angle XZW is congruent to angle YZW. We use this word bisects. It's the definition of an angle bisector. Way back when we did those angle proofs, we used angle bisector once in a while. Okay, and look, here's another pair of angles. So we throw side angle side out the window because we have two pairs of angles. So now we either need the side in between them, which would be WZ and YZ, or another side, a third side. Not in between them. Well, look at the triangles. They touch. They share WZ. Okay? WZ is congruent to itself because it's the same side in each triangle. Remember, when you look at each other, it's a reflection, so it's the reflexive property. Remember, I said you're going to use that a lot. And this is a side. So, both of these reasons have two angles and a side, but the question is it the side in between the angles or not? And the answer is not. It is not the side in between, it's another side. So, throughout the side in between, this is our way to prove triangles congruent. So we can now say that the two triangles are congruent. Triangle WZX is congruent to triangle WZY by angle, angle, side. Okay. All right, I would like to do one more. I think the more practice you get, the better you'll be at these proofs in class. All right, so again, pause it when you see it, copy it down, and then we'll get going. Okay, so here's a great example. Okay, this is a great example because it ties in chapter 3 into these proofs. Okay, so we are given that segment AB is parallel to segment CD, and we're given that segment AB is congruent to segment CD. And the question is, can we prove that triangle ABD is congruent to triangle CDB? Okay, so as we always do, the first is the given. The first statement is the given. And let's see what we can mark. Well, we can mark lines parallel. AB is parallel to CD. We can also mark that segment AB is congruent to segment CD. And now notice, there's one of our sides. So if we look at our four ways, side, 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 angle, side, angle, and angle, angle, side. Each of them have at least one side, so we're all up for grabs. All up for grabs. Okay. Now what in the world is this going to mean for our picture? The fact that these lines are parallel. Well, watch this. Watch this. Let's extend the parallel lines. And let's extend BD. Okay? This BD, sorry, not right there. Is a transversal. It's a transversal going through two parallel lines. So the question is, do those four angle relationships, is one of them going to help us here in this problem? Well, again, it has to be the angles formed by the parallel lines and the transversal. So this line AB and this transversal form this angle right here. Right in there. ABD. This line CD and this transversal BD form this angle right in here. So the question is, do we know something about these two angles? Are they one of those special kind of angle pairs? And the answer is yes. They are inside the parallel lines on alternate sides of the transversal. These two angles are alternate interior angles. We can use that idea, the alternate interior angles theorem. We can use that idea to talk about two angles. Angle ABD being congruent ABD to angle CDB. A, B, D, C, D, B. They are congruent. And here's another part, angles. So by SSS, we throw it out. So we have one side and we have one angle pair. So since the lines are parallel, all alternate interior angles are congruent. And now, just like the other ones, the triangles touch. BD is congruent to itself. Reflexive property. All these proofs have involved the reflexive property. Very important. Reflexive property. Side. Throughout angle, angle, side. So the question is it side, angle, side? Oh, and throughout angle, side, angle. So it has to be side, angle, side. Let's check. BD is congruent to itself. Side, angle, side. Side, angle, side. Perfect. Perfect. This is side, angle, side. So we can go ahead and say that the triangles are congruent. Triangle ABD is congruent to triangle CDB. And the reason is side, angle, side. Okay, so hopefully you didn't think that was too bad, and you'll have more proofs to complete in class. All right, thanks for watching. We'll see you on Wednesday.